Hello, good people. Welcome back. We are trying out this new method to find antiderivatives of complicated looking integrals. It's called U substitution because we're going to replace the inner function, what Brian calls the junk, the complicated part. We're going to replace it with U, the variable U, and then we're going to try to take the antiderivative there. But replacing the U is not enough. We also need to replace the dx. And so that's what we're doing here. So let's start with number one. We have already identified what the U is, but now I need to replace my dx for x. Now there's different ways to do this. I'm going to admit that there are different ways to do this, but here's one way to do it. In order to replace a dx with a du, according to this, I call it the exchange rate. According to this exchange rate, I can exchange a du if I have 2 dx. But if you look at the integrand, I do have 2 dx because I have 2 dx. So what I'm going to do is I'm going to replace, and maybe I shouldn't put an equal sign. Maybe I should say this is going to become an integral of sine u, because I'm going to replace the 2x with a u, and then I'm going to replace the 2 dx with du. And in doing so, I've simplified my antiderivative, right? My antiderivative is now take the antiderivative of sine u du. Well, we can do that. The antiderivative of sine u du is negative cosine u plus c. And so here, excuse me, here's what we did. We found u, identified the u, we found du. That was in the first video. Now we're going to substitute the u into the original problem, and we're going to fix any constants needed to make the du work. We didn't need to fix any constants because we had what we needed. We had 2 dx. I need a 2 dx to replace it with a du. And then I'm going to integrate using one of the antiderivative formulas. We did. And now the last step is, okay, now take it back to the original variable. My original variable was x. So this whole thing becomes, and I'm going to write the answer in purple here, negative cosine of u, which was 2x, plus c. And there is my antiderivative. U substitution allows us to make a complicated looking integral a little less complicated looking so that I can take the antiderivative. But then I have to keep in mind, if I'm doing an antiderivative, I got to go back to the original variable, which is what I did here. So if you think about it, I kind of went from here to here, from here to here, and then I went back. That's it. I say that's it, but yeah. Let's look at example 3 right under it. Let's try this process. Excuse me. So let's replace some things. Okay, so do I have enough to replace? I have my u taken care of, right? Whatever's in orange, I'm going to replace it with that. But I need 2x dx in order to replace it with a du. But I only have 1x dx. And so in this recipe, it says fix any constants needed to make the du work. What does that mean? Well, I need 2x dx. I only have 1x dx. So I could multiply this by 2, but that's going to change the whole value of the integral unless I compensated by multiplying by 1/2. So if I multiply 1/2 times 2, that's 1. That would be the original integral, right? But I need this 2x dx in order to replace a du. So let me introduce this constant multiple. But if I do that, I got to balance it out with a 1/2 that I'm multiplying on the outside, with its reciprocal on the outside. So now here's what I have. 1/2 on the outside. The green part is going to become du. And then the other thing that's left over is e to this orange part, but the orange part was u. So look at how cleaner my integral looks. It looks a lot simpler. And you and I both know what the antiderivative of e to the u is. And so I can take the antiderivative now, but remember that we are in the world of u's, not the world of x's. And so when I do this, this will be 1 half e to the u plus c. That is the antiderivative, right? The antiderivative of e to the u is e to the u. And because I had a 1 half constant, I just multiply it back in. Excuse me. But now let's put it back in terms of x's. So that would be 1 half. Let me do it in purple because I did the other one in purple. 1 half e to the x squared minus 1 plus c. Where did this come from? Oh, that's what u was worth. U was equal to x squared minus 1, so I just replaced it back, and now my answer is complete. So the antiderivative of this original integral is 1 half e to the x squared minus 1 plus c. And that's it. That's it. Okay, so I'm going to pause here. We're going to come back. We're going to finish the other three, and then we'll talk about maybe some more complicated looking integrals that we can work.